Good morning all. I will take this opportunity to welcome all the participants for today's workshop on Innovation through Ideation with our guest speaker Dr. S. Satish. Before starting the session, I would like to give brief introduction about the college and the department. So Savita Institute of Medical and Technical Sciences, SMATS, is a fast-growing educational institution with a sprawling campus close to Chennai city. Recognized globally for its academic excellence, SMATS today is a vibrant community of the learning. The university is accredited with A++ grade by NAC and as IET UK accreditation. So the Department of Electrical Power and Energy Conversion, SMART School of Engineering offers strong undergraduate and postgraduate programs with an active research-based curriculum to provide the technical education needed by the engineers in the technology-driven world. Now, we would like to welcome our guest speaker. Welcome, sir. Let me give a brief introduction about the guest speaker, Dr. S. Satish. So, he has completed his PhD in the year of 2016 from Satyabama University. Currently, he is working as professor in the Department of Chemical Engineering, Satyabama Institute of Science and Technology. He has also worked in Manali Petrochemical Limited. So, he has published more than 40 papers in reputed journal with cumulative impact factor of 68.112. He has also published 2 patents. So, I am handing over the session to you, sir. Please tell me.
Okay. Good morning to one and all present here. It's thanks to the organizing department for giving this wonderful opportunity to deliver this lecture today to motivate yourselves to the innovation part. So as we are in the current trend towards the technology development, innovations, so we are having a wide scope in innovation capabilities. So what are all the opportunities when we are working in the innovation part? So as we are entering into a new technological era, new educational policies, we are focusing on startups. So what are the innovation capabilities regarding an energy and environmental department is organizing? So today we are discussing about the innovation capabilities in biorefinery in the perspective of sustainability. So sustainable environment. So anyone can know what is meaning of the sustainability? What do you mean by sustainability? What is sustainable? Existence. So when we are saying about the sustainability, we are using the resources for current usage and also we are protecting for the future environment, the ability to. So the title of today's topic is Innovation Capabilities in Biorefinery from the perspective of sustainable, a way to the sustainable environment. So when we are saying about the sustainable, it is nothing but we are utilizing the resources. At the same time, we should not deplete the resources and we are keeping for a future generation. That is said to be a sustainable environment. As we are technologists and engineers, we have to design sustainability and we have to protect the environment, sustainable environment, and the engineering aspects without depleting the environment and making the pollutions. So that is sustainable engineering. The technology part, the design part, at the end, ultimate use is to protect the environment. So when we are sustainable engineering, the main aspects which comes is what are the wastes converted into wealth. And we have to minimize the waste generation. Either you can avoid the waste generation or minimize the waste generation. And you can modify the technologies so that the engineering part of design is sustainability. Sustainable, again I repeat, it is utilizing the resources and you are not depleting the resources and you are making availability for our future generation. So this is about sustainable engineering. Then when we are discussing about the sustainable design, so what are the new materials, what are all the design parts, and what is the modification designs that we can discuss in the sustainable design. And environmental sustainability, So we are protecting the national capital, maintenance of biodiversity, maintaining the energy balance, materials which we can use in 4R techniques: recycle, reduce, recover and reuse, recycle, and health and resilience of all the life support systems. How to achieve this sustainability environment? By reduce the dependence on the non-renewable resources, effective use, and you can use the 4R techniques, and you can use mostly a biodegradable, environmental, eco-friendly substances. So today topic we are discussing about how we are producing the biodiesel from using the sustainability concepts of sustainable engineering, sustainable design, and thereby we can achieve sustainable environment. So you know, petroleum refineries, their naphtha, crude oil concepts are there. You will having a kerosene, biodiesels, diesels are there from the natural part. And you know about the hydrocarbon fuels, that is C1 to C4 petroleum fuels, naphtha, then gasolines or petrols, kerosenes, gas oils, lubricating oils. These are all already you are studied in the, as these are all taken from non-renewable resources. Main sources coal and crude oil we are taken for the hydrocarbon fuels. So now we are focusing on renewable energy, so that we can use, we can maintain the environment pollution free, and also for maintaining the sustainable environment. So national policy on biofuels. So 20% of blending will be possible by the biodiesel, bioethanol by the year 2017. So biodiesel produced from edible and also from non-edible oil seeds. A minimum source support price will be direct. Financial incentives are given for the production of biodiesels. This will focus on sustainable environment. So biorefinery concepts. So what is biorefinery? You know, already we meant by refinery parts, where we are recovered crude oil processing. From crude oil we are producing various components, that is refinery. So when we are saying about the biorefinery, we are utilizing the bio resources, that is waste products, either it may be agricultural products, agricultural seeds, or edible or non-edible seeds. From that you are undergoing a process of transesterification, thereby you are producing biodiesel. So this process is said to be a biorefinery. When you are compare the refinery process and biorefinery process, the pollution free process, biorefinery process, emissions are very less when you are comparing to hydrocarbon fuels. So biofuels are the fuels which derived from the biomass, organic material. When it is burned, it will release energy. So we are having various generations of biofuels which we have come across. First generation fuels we are using from starch, vegetable oils. Second generation is advanced biofuels from the lignocellulosic biomass. Third generation biofuels, we are biofuels from algae, and now we are using a pyrolysis techniques. So biomass, as I already mentioned, it is a renewable source. It will not contaminate and not pollute the environment, and the emissions, greenhouse gases emissions is comparatively less when you are going for hydrocarbon fuel. So we are generating biomass. What is biomass? It's a heterogeneous matter, maybe a living organisms or agricultural products. Bioenergy, we are developing the energy by using a biofuel. It's said to be bioenergy. So what are all the products? What are all the products of biorefinery? When you come across the biorefinery, the first product is a biofuel, and also we are generating heat and electricity from the bioenergy. So that's also there. Thermal energy you can produce, electrical energy you can produce, and also you are producing biofuels for locomotives. So we are discussing about 4 different industries for generating these biorefineries. One is lignocellulosic biorefinery platforms, where you can use sugar or cellulosic materials for producing biodiesel. Then the second one is from paper and pulp industry. The third one is sugar industry. Enzyme industry, by using enzyme technologies, we are producing biofuels. So first one is paper and pulp. So when you are saying paper and pulp, the major product for major raw material you are using is woods. You are generating papers. So there you are producing more amount of waste like cellulosic materials. From that you can take the product raw materials, that waste can be taken. From that you are producing a biofuel, that is we are producing a biofuel from paper and pulp processing industries. Second one is beverage processing industries, where you can produce alcohols from sugarcane molasses. From that, the molasses will be taken, that will be used for the production of biofuel. By means of fermentation technologies also you can undergo. So this is a second industry you can use waste resources. So first resources we are taken from paper and pulp industry. Second industry we are taken from beverage processing industry. And third one is nothing but enzyme technologies. You can use enzymes as a catalyst process for producing the biofuel by transesterification process. Then anaerobic digestion process, where you can produce the biofuels which can be used as a composting technologies from food products or from sewage. You can use the anaerobic digestion process for producing these biofuels. Then the fifth process is nothing but algae processing industries. From the algal oil will be taken. That algal oil will be the source for biodiesel productions. So we have come across 5 different industries for producing biofuel. One is paper and pulp, the waste from the paper and pulp industry. Second one, beverage processing industries, molasses will be taken as the waste. Third one, we are having enzyme technologies. Fourth one, anaerobic digestion of waste. And the fifth one is algae processing industries, where you are cultivating algae. So cultivating algae means for using of the wastewater treatment, where the overspread you can produce algae, then algae can be recovered. That algal biomass, from that algal biomass you can take the algal oil. That algal oil is as a source for biodiesel, and you can use that algal biomass as a wonderful absorbent properties. That also you can use for the treating any contaminant problems. So there are multiple advantages when you are seeing about algae processing industries. So these are all the 5 different industries we are comparing: paper and pulp, beverage, enzyme, anaerobic digestion and algal sequestration. So from that, all the products you are taken, one product is biomass and another one is waste management. Simultaneously you are controlling the waste and also you are producing the useful process of biomass. That integrated process we can use as a biorefinery process. Combination of the waste recovery and also biomass conversion. So then next we are going to see about some other process which we are having, food processing industries. You know, food we are consuming every day and we are using for the purpose. That food processing industries we have developed a lot of wastes, food shells. From that we have taken the part and that food wastes we have collected. That food waste can be used for the synthesis of novel catalysts that can be used for biorefinery, biodiesel process. So anyone can know how you are producing biodiesel? How you are producing biodiesel? From algae. So the general process for biodiesel production is nothing but transesterification. So you are taken the vegetable oil or non-edible oils that you can take as a feedstocks. From that you are using a methanol as a reactant. Then you are using catalyst. Then by means of the transesterification reaction you are producing biodiesels. So there are various non-edible feedstocks which you can use for biodiesel production. So you are also using the waste cooking oil. That waste cooking oil can also be used as a biodiesel productions. So either you can use the cook oil, either it may be a fish fry oil, or you can use vegetable oil which will be recovered from the hotels. That can be you can taken out and you can use for the conversion of biodiesel. So use cooking oil, animal fat conversions for the biodiesels. So generally we have come across the process called transesterification. So the catalyst initiate the reactions and allow the fatty acid chains to detach and react with the methanol to form a fatty acid methyl esters. That is generally it is called as FAME. So either you can use the acid base catalyst. So strong base catalyst like sodium hydroxide and potassium hydroxide is usually used that is nothing but homogeneous catalyst. The major drawback in homogeneous catalyst is it will be dissolved with the reactants and it will be goes on in the washing. So when the fatty acids plus methanol plus the homogeneous catalyst will give you the biodiesel plus glycerol. This biodiesel and glycerol will be separated by density difference, and the biodiesel will be further washings. The NaOH and KOH will be washed away. So you are wasting the catalyst and you are utilizing the spent amount. Now for that we are making an innovation in the catalyst generations. Nowadays more amount of catalyst will be developed. So by using the waste resources, that can be used as an innovation part when you are saying about the biorefinery. So catalyst generation is an innovation thing when you are thinking about the biodiesel. Then strong acid catalyst, sulfuric acid catalyst also we are using. Then enzymatic catalyst and heterogeneous solid catalyst. The one of the best advantages when you are discussing about the heterogeneous catalyst is this catalyst can be recovered and you can reuse for the further purposes. So why we are going for heterogeneous catalyst is these catalysts can be used once and you can recover it, recycle it and reuse it. So the 4R techniques will be applicable for heterogeneous catalyst. So the innovations part when we are using is how we are regenerating the catalyst, how we are recover and the process of recycling it, that we can discuss in the alternative innovation scope. So the biodiesels, this is a chemical reactions which there. So the fatty acids from the oil, either you can take in as an edible oil or non-edible oil, react with the methanols, will give you a fatty acid methyl esters, that is nothing but biodiesel, and the byproduct is glycerol. So biodiesel conversions, you are taking that alcohol into oil ratio based on that, and you are adding a catalyst, you are producing biodiesel and glycerol. This biodiesel and glycerol will be separated by density difference, and biodiesels will be produced for further washings with the hot water to remove the traces of sodium hydroxide and potassium hydroxides. If it is in the case of homogeneous, or in heterogeneous case, it is filtered and you can remove this catalyst. So biodiesel processings, first you are taken the oil, you are removing excess fatty acids, then you are going for transesterification reactions, then glycerol separation and byproduct separations, water washings and drying. So when we are saying that when you are producing the life cycle assessment of the entire product and techno-chemical and techno-economic analysis of producing these biorefineries, when you say life cycle assessment, it is nothing but a cradle to grave concept. So what we are producing, what we are taken and what we are producing, where all the impacts will be there, that we can say in the life cycle assessment. When we are saying that we have started the product from waste recovery. We have taken the used oil, non-edible oils. Most of the non-edible oils we have taken. Algal biomass we have taken. That entire waste product where you can use the waste resource, waste minimizations. That waste can be used and you are generating a novel innovative catalyst and you are producing a biodiesels. So from the waste only you are producing the biodiesels. That will be a good sign when you are considering the sustainable environment. So you are what feedstock you are taken, what is the methodology you are following, and what is the end use when you are comparing this entire process which comes under life cycle assessment. So life cycle assessment, we have taken the input which is waste, which will be discarded and which will be contaminate the environment. That waste we are minimized by producing a useful product, that is biofuel. So the output is useful, input is from the recovery of the waste products. And the technology you are using is novel innovative catalyst by using an heterogeneous catalyst by undergoing a transesterification reaction. So we are using the input and the lead and output will be a sustainable one. So we are finding the sustainable technology producing transesterification. We are producing sustainable design of producing novel catalyst, and we are producing a sustainable environment which reduce the waste, and also we are producing a eco-friendly products which is a biofuel which will deplete the resources, which will reduce the usage of petrol, that is non-renewable substances. So we are identifying the goal we have set the definition, scope and analysis, and you are assessing the impact. So the only the impact when you are analyzing the biofuel is you are producing the biofuel, that biofuel greenhouse gas emission will be less. So we are identified a path which is a goal and scope, whether the process will be there. So there are more scope when you are going for a startup industries. Startup scope will be there when you are producing for any other biofuels from the novel catalyst. You are identifying goal. Stipends are provided by our government, so that we can check it out as a life cycle assessment of the entire product. This project, when you are saying a biorefineries, it will be a good sign. So we are analyzing what are all the inventory cost. You know inventories analysis, because when you are going for any startup, you have to identify what is the capital cost investment. We are using the waste resources. Only when you are saying the capital cost will be using a capital investment for construction of a reactor and separation sections. With the resources which will be available in plenty, waste resources which will be available in plenty, so that will be not having a higher cost when you are comparing to any other projects. So you are producing electricity, so it's nothing but a captive power plant. You can produce your own power, thereby you can save the environment. So when next come, these are all the life cycle assessment framework. So you are identifying the goal, definitions, scopes, inventory analysis, and impact assessment. So you are identifying the issues. What is the issue? Major issue is you are identifying this issue today. One issue is how you are save the environment from more amount of waste generated. Waste, when I am saying it's food waste, also is a waste. And more amount of waste generation, biomass is also a waste. So how you are handling the waste management. And second thing, you are using a plenty of non-renewable resources. How you are overcome that, how you are producing for the future generation, how you are keep these resources for future generation. So the sustainability will also having a goal. So we are identifying two goals. One is waste minimization and another one is sustainable. And we are defining the product by means of achieving a biorefinery, that is producing a biofuel which will be save the environment by sustainable design and sustainable technology. And we are identifying the significant issues. We are evaluate the process by means of transistor esterifications. We are producing, comparing the homogeneous catalyst and heterogeneous catalyst. Heterogeneous catalyst will give you the best when you are comparing to homogeneous, because homogeneous that will be washed away when you are doing a biodiesel purification. So you are going for heterogeneous catalyst, and you are identifying the sensitivity part, what is the biofuel, what is the useful, and what is the blending part will be there. And when you are checking the greenhouse gas emissions, it is very less when you are comparing to petrol and diesel fuels. So you are identifying the contributions, you are identifying the uncertainty parts which will be there, and the sensitivity scopes we are identifying. And finally we are comes to a conclusions, thereby you are producing the life cycle assessment of the entire process, that is a biotransesterification process, and you are performing the environmental impact analysis. When you are checking out what is the each and every stage of the project, you are identifying what are all the impacts which will be created. Either it may be a positive impact or it may be the adverse impacts. So when you are identifying this, most of the scopes we are covering a positive impact. So we are reduce the wastes, we are producing an alternative techniques, we are recovering the wastes, minimize the waste, and minimize the emissions of the particulates, and you are producing a novel biofuels which reduce the consumption of non-renewable resources. By that environmental impact analysis, when you are identifying, it is the positive impacts when you are creating a biorefinery parks. So when you are identifying the technical and economic analysis, how the materials can be used, it will not generating the cost and the process charges, and you are producing the fuels which will be for the future generations. So when you are comes to conclusions and take home messages, what you are taken from that, you are known what are all the problems which are associated with the fossil fuels, how you are producing a biofuels from the various products. So we are defining the 5 different industries, that is paper and pulp, beverage, sugar cane processing industries, anaerobic digestion from waste products, algae industries. We have taken 5 different industries. From the 5 different industries, you have collected the waste resources that you can produce the biofuels, and you are known that increasing the fuel demand nowadays. So for that, you are producing one alternative resources, that is nothing but renewable resources. And you know what is about the biorefinery concept and what is nothing but a transesterification. From that, fatty acids will be converted into fatty acid methyl esters, that is nothing but biodiesel. Then you know the bio process in the biorefining process, that is methyl oxide process, transesterification, glycerol purification and catalyst recovery. So these are all the process, and it knows that these 3 parts which comes under the sustainability part: sustainable design, sustainable technology, sustainable environment. And finally, you know biorefining process and what are all the various available feedstocks. So that we are having a more scope in innovations in identifying the waste resources and identifying the various innovative catalysts. So you are having a more scope of innovation part when you are saying about the biorefinery. So today we are having an innovation in ideation. So we are having an idea for generating a biofuel so that it will be useful for your projects by innovating any feedstocks, various feedstocks. You know, non-edible oils. What are all the agricultural products which are having non-edible part, which you can recover oil. From that oil, you can able to check it out whether you are producing biodiesel or not. At the same time, what are all the various catalysts available, and what are all the various heterogeneous catalysts can be synthesis. For that ideation part, you have to think. So these 2 innovations will lead you, that will ignite you today. So thank you. Any doubts? Thank you.
Thank you, sir. Thank you for your valuable lecture. You have enlightened us with the more technical inputs of current scenario. Thank you so much, sir. Now I will call upon Dr. J. Aravind Kumar, sir, and Dr. B.T. Gita ma'am to give a memento to our guest speaker.
Only camera on up now. Yeah, I'm pretty good.
Now I would call Dr. J. Aravind Kumar, sir, to give vote of thanks.
Good morning to everyone. First of all, I thank our director madam for providing a constant support towards the conducting of this IAC workshop. Secondly, I would like to thank Principal Sir and the Vice Principal Sir for their support towards this workshop. Next, I would like to thank the faculty, the Department of Electrical Power and Energy Conversion for their support towards the organizing the IAC workshop successfully. Last but not the least, I would like to extend my sincere thanks to the students for your patient listening and your constant support towards the IAC workshop. Thank you, one and all. Students, now you can disperse to the mentor meeting.